Hello all. We have seen in the previous videos about doing slope stability in Slide software, RS2 software and in GeoStudio. In this video, we will do the analysis in Midas software. We have already saw that for every software, the basic steps are geometry creation, material properties creation and assigning, then assigning boundary conditions and then solving the problem. Here also, the steps will be similar. Midas GTS and Midas F E A both are nowadays having same features. Here we are using Midas F E A. When we open Midas, it looks like this. From here, we can start a new file. The first screen appears like this. Here we can select the model type. This software is capable of solving 3D problems as well as 2D problems. If we are selecting 3D, then accordingly, gravity direction has to be selected. If it is 2D problem, by default, gravity is selected. Here we are selecting 2D and proceeding further by keeping remaining all as default. After clicking OK, we get the main page. Here we can develop and work. Like all the softwares, first we have to create geometry, then creating materials, assigning boundary conditions and load conditions and solving. Tabs at top ribbon will have all these options. Now we create geometry. There are several options. We can create points, lines and polylines and so on. We'll start with polyline. The important point here is to giving the coordinates of polylines in absolute coordinate system or relative to previous coordinate. We will create the geometry of our problem. After creating geometry, next we'll click Mesh tab. In this Mesh tab we have options to define materials, define material properties and mesh creation. Materials means we have to create materials corresponding to their behavior with their properties. In our problem, we are considering soil, so we are creating soil with parameters as entered at the respective places. Structure box is unticked. It is used only when it is concrete or superstructure components only. So here we are unticking structure and defining material. We can see the material we defined here. Like this we can create multiple materials and also delete or edit them. Now we have to define property type. Because some materials in the model may be one-dimensional and also some are two-dimensional. Using this tab we are creating two-dimensional property corresponding to soil material. Now we have defined material and also defined its property. After this, we will have to do meshing. Here we are selecting two-dimensional meshing. Here it is to note that lines, the software says as edges. We have to select the lines and accordingly define the mesh. Here for particular closed boundary we have to select the material in parallel with mesh creation. After completion of mesh, it will look like this. The left tab's Model, Analysis and Results are useful. Model tab, we have all the geometry created and also we can see created meshes. Now we'll see creating loads and boundary conditions. Here, we are not considering any loads except gravity. The red color arrow at the center of geometry is gravity loading. By default software is showing it, so no need to add it. Then we have to add boundary conditions. Bottom is fixed, whereas the side verticals are not allowed to move in horizontal direction and allowing vertical settlement. If we select auto, then the same will be applied to model. We have completed all the modeling. Now we have to create analysis. Once we create analysis, we have to active the necessary mesh sets, loads and boundary conditions. In this software, whatever we have activated, those only will be considered for solving. Here we are using strength reduction method. Once everything is completed, we solve the problem. Once the solving is completed, we can see the results. As informed already, results are checked in different tab next to Analysis tab. In the Results page, we have different options to check our results as per our need. We can check stresses in different directions, settlement or translation in different directions. Also, particular value at different nodes, also we can get the information. For this problem we are getting 0.57 as strength reduction factor. That is, this slope will fail. This is same as we got in other softwares also.